So this video is on combining resistors. So hopefully by the end of this section you'll be able to calculate the equivalent resistance in series and parallel circuits. When we talk about equivalence resistance, what that means is combining whole networks like this and reducing it down to just one resistor. Okay, so what I'd like you to do is to follow the next set of instructions that appear on this video using PhET to complete an investigation on combining resistors. Okay, in this video, again, still using the same PhET animation, what I'd like you to do is we're going to investigate combining resistors. Okay, and what we're going to do is we are going to use again our voltmeter and ammeter to measure the overall resistance of this circuit. So to do that, what we're going to do is place the ammeter right next to the battery. This way you're going to measure the current coming out. And we're going to start off with one resistor. Now we're going to make all our resistors the same. You don't have to, you can vary the resistance of these as you go on. Okay, so I'm going to now place 3 resistors. Well, let's start off with just 2 with one resistor. So I'm going to place one resistor in our circuit. And what I'd like you to do is to record then the current and the voltage across it. Again, you can use Excel. So let's just remove our previous experiment. Okay, so what I'd like you to do is to have a column that says number of resistors. And we'll make a note, each is 10 ohms. Make sure we don't leave it as W. We'll change it again back to symbols so we get the right symbol. There we are. So each one is 10 ohms. We will then have voltage in volts and current in amps. And then we will have overall resistance, which we will measure in our ohms. So let's just copy that over. Okay, so our columns we've got, just go from that shape, don't do that. Number of resistors, so we have 1, 2, 3, 4, 5. And we're going to add these number of, let's say, series resistors. Okay, each is 10 ohms, so we're going to have our voltage, we're going to have our current, and we're going to have our overall resistance. So that what I'd like you to do is in this cut box, you can do equals voltage divided by current, because that's how we work out resistance. Don't worry for now that it's got divided by 0. When you fill out your results, this will populate itself. Okay, so pause video now, conduct your experiment. Okay, welcome back. So here are my results. Okay, so I have got number of resistors here, I've got my voltage and my current I record, and I've got my results here. Now remember, each resistor we added is 10 ohms. So what do we notice? Hopefully what you notice is that as we increase the number of resistors in series, the overall resistance adds up. Alright, so adding 2 things in series, their resistance adds up. Simple. Right, on to parallel then. So we need to change our table. I'll tell you what, we'll leave that one. Let's copy and paste this table below. Okay, and we're going to have number of parallel resistors. Alright, so leave your top table, let's have our bottom table. So we're going to have a number of parallel resistors. Okay, so we delete our current column, and we can delete our voltage column. And let's go back to our things. So, to set these up, what we're going to do is, let's break apart these joints, like so. Again, set up one resistor. This time do it right away at the top, and you want to be measuring the voltage really coming out of the cell. That's the voltage that we want, because we want the overall circuit like so. So we start off again. 1 is going to be 9. and 0.9. Okay, and then when you add in your second one in parallel, like so, add it below, and we get this. Okay, and what I'd like you to do is to now pause the video and do it for up to 5 resistors again. Alright. Okay, welcome back. So, I've got my results here. Yours might be slightly different, but there we are. So I've got my results here. So hopefully the first thing that you can notice is that adding more resistors in parallel, each one we add, the overall resistance goes down. So we start off at 10 ohms and we've ended up with 2 ohms by the end. So adding things in parallel reduces the resistance. And in fact, what we actually have is this equation is quite a tricky one. So what we are actually doing here is we are now adding the reciprocals of the resistor. Okay, so hopefully you've completed the investigation and you found out that when resistors are in series, we add their resistance, and then resistors are in parallel, we add their reciprocals, or adding more resistors in parallel, the resistance gets lower because we are adding fractions each time. Now it's important when we use this formula, you add 1 over, so this is 1 divided by resistance, so you use your calculator properly and do 1 divided by resistance plus 1 divided by the next resistance. And then when you've got your answer, to find the overall resistance, you must do 1 divided by your answer. Okay, so what I'd like to do is to complete the following table using the formulas given. Pause the video whilst you're doing this. Okay, welcome back. Hopefully you've completed your table and we do this. So the first 3 are in series, so we do 2 plus 5 is 7. 15 plus 470 is 485. 33 plus 47 is 80. Now on to the tricky bit. These are in parallel, so we do 1 over 2 plus 1 over 4 equals, so let's draw this on. So 1 over 2 plus 1 over 4 equals 3 over 4. And then what we have to do is we do 1 divided by 3 over 4, and that equals our 1.33. Okay, so our next one is 15 and 25, so do the same here. 1 over 15 plus 1 over 25 equals, now this is a tricky one to do, and the easiest way, if you're doing these on your calculator, the calculator will do them straight away. If you're not doing them on a calculator, then what you'll have to do is multiply the bottoms by each other to get their lowest common multiple, and we go from there. So we do 1 over 25 plus 1 over 15 gives us 0.106, and you might notice above the 6 there's a dot reoccurring. So we then do 1 divided by 0.106 reoccurring, and we get an answer of, now off your calculator what you'll get is 9.37, which you can see is roughly the same as 9.4. Right, and then this last one, so this last one, what you need to do is you need to do this bit first. So you do 1 over 100 plus 1 over 100, which gives you 2 over 100, and then this is the equivalent of having a 50 ohm resistor, and we do 50 plus the 66 because they would be in parallel to give us our 166. Okay, some more examples for you to now do. Again, what we'll do is get on to an example, and you pause the video whilst you're working it out. Okay, the first one is 65. because what you're going to do is 50. We've got a parallel bit. So we do 1 over 50 plus 1 over 50 is 2 over 50. So therefore the resistance of this is 50 upon 2, which is 25. And then we do that plus our 40 to get 65. Okay, a trickier one. So again, same principle though. Work out this bit, then work out this bit, and then add your 3 resistances together. Pause the video now to do that. Okay, excellent, welcome back. Hopefully you've got an answer of 132. So to get 132, you're going to have 1 over 100 plus 1 over 200. So that's going to give us a resistance of 1 over 100 plus 1 over 200 equals, that's going to be 4 over 200. So our resistance is going to be 200 divided by 4, which is 50. Brilliant writing there. This one is going to be give us a resistance of 25. And then I've made a mistake here, have I? That's going to not be 4, that's only going to be 3. Whoops, that's 3, which means that that's wrong. So 200 divided by 3 is 66.6 reoccurring. That's better. So this plus our 40. So we've got 80 plus 40, yeah, comes to 132 out of them, rounding to the nearest whole number. Okay, what about this example then? Same process yet again. Oops. Put that out. Do this bit first, then add it to this one, then add it to this one, and then add it to this one. Pause video now to get your answer. Okay, welcome back. Hopefully you got 63. Now how do we get 63? So we do this bit first. So you're going to do 1 over 20 plus 1 over 40 equals 3 over 40. So therefore the resistance of this is 40 over 3, which is 13.3 reoccurring. So we do 10 plus 13.3, so that's 23. Add 15, add 25, and we get an answer of 63. Okay, what about this one then? Okay, right. Hopefully you got an answer of 450. How do we get an answer of 450? Well, these two added together is 50. And then we add the rest together and we get 450. Quite straightforward, that one. Okay, what about this one then? Okay, ready for an answer. So we've got 3 in parallel now. So we're going to do 1 over 50 plus 1 over 70 plus 1 over 30 to give us into the calculator. Okay, so this gives us quite a horrible fraction to begin with, 0.0676, and there's a few more digits. So the resistance of this is going to be that number, 1 divided by that number, which is 14.78. So we now do 40 plus 14.78 and we should get an answer of 55 to the nearest whole number. Okay, now this is the last one. Now this is the trickiest style of question that they can give you. So what you should do is, for this question, if you don't want any help, pause now. Otherwise, what I'll do is I'll go through different stages, pausing at different times. Okay, so the first help. We need to break this down into easy bits. So we've got our first bit is to do that. Our second bit is then to look at that combination. And then the final thing is we look at the overall combination of everything. So, off you go. Okay, welcome back. Right, so, starting off with the red bit, 2 in series, so that's adding them together, 20 ohms. Then we will look at the green bit next. Is that green? So I've now got a 20 ohm in parallel with a 20 ohm, so that is the same as having a 10 ohm resistor. And then we look at the blue bit, and we've got a 10 ohm resistor in parallel with the 10 ohm resistor, so that is the same, whoops, as a 5 ohm resistor. And hopefully the answer is 5. And it is. Correct answer of 5. Okay, so hopefully that's helped you with the resistors and resistor networks. And what we will do now is, moving on, the next step is to apply Ohm's law, V equals IR, and our laws on resistors to be able to solve the current and voltage through a series of circuits. Okay, thank you very much.